Okay, this interface that connected to the switch 2 in this link is the designated port. Let me to review. Look at here. We are finding the designated port on the link between switch 2 and switch 3. Okay, on this link. Here we have two interfaces, the first interface and the second interface. We need to find the cost of the switch connected to this interface to root bridge. Here we have the cost of 4, and also here we have cost of 4. And because of that, now we have a tie. And how we can solve the tie? It's so easy. We need to use tiebreakers. The first tiebreaker says that lower sender bridge ID is the, for example, designated port. As you can see here, the switch 2 and switch 3 are two switches that are connected to this link. Because of that, we need to compare the switch 2 bridge ID and switch 3 bridge ID, because the switch 2 bridge ID is less than is lower than the switch 3 bridge ID about the MAC address. This interface connected to the switch 2 is the designated port on this link, and actually we can say that here on the port 2 of switch 3 is the alternate interface. Because of that, as you can see in this example, we are experiencing the tie about the designated port, not the root port, but both of them, designated port and root ports, are using the same tiebreakers. Okay, let me to explain this scenario, the right scenario. Here we have again switch 4, switch 5 and switch 6. The switch 4 has lower or lowest value about the MAC address. Because of that, it's easy to understand that the switch 4 is the root bridge. Let me to write here. This is the root bridge. Now we need to find the root port. The switch 5 has three interface, 1, 2 and 3. Cost of the interface 1 has lower than the cost of interface 2 and 3 to reach to the root bridge. Because of that, the port 1 is the root port. About the switch 6, we have the same condition. The port 1 of switch 6 has lower cost in compare with the port 2. Okay, because of that, this is the root port. After that, between the here now we selected the root ports on all switches except the root bridge. We need to find the designated ports. Again, all interfaces of the root bridge are the designated port. This is the designated port. Okay, and after that we need to find designated port on this link. In this link we have for the first time experiencing one segment, one link with three interface: port 2, port 2 of switch 6, port 2 of switch 5 and port 2 of switch 3. We need to find the designated port between these three interfaces. All of these interfaces are residing in one segment. Hop does not have any effect, you know it. Okay, because of that we need to compare these three interfaces with each other. The first rule is the lowest bridge lowest for example cost. The cost of switch 5 to root bridge is 4 and the cost of switch 6 to root bridge is 4. Because of that we can't find the designated port with cost. The next tiebreaker, the first tiebreaker, is the lower sender bridge ID. Again, about the lower sender bridge ID, we need to compare the switch 5 bridge ID and switch 6 bridge ID. Because the switch 5 has less or has lower value about the bridge ID, now the port 2 and port 3 of the switch 5 has a preference to the switch port 2 of switch 6. Now we need to find the designated port between these two interfaces, the port 2 of switch 5 and port 3 of switch 5. Look at here, we have three ports in switch 5. Okay, switch 5 port 2, fast Ethernet 02, and also fast Ethernet 03. And after that, in switch 6 we have one port, fast Ethernet 02. With first tiebreaker, the lower sender bridge ID, we can understand that this port, the port 2 of switch 6, is not designated port. But now we have again two ports that both of them are using the same sender bridge ID. Then the next criteria about the tiebreaker is the lower sender port ID. Okay, and after that, lower local port ID. The last tiebreaker can be useful here: lower local port ID. The port ID of the port 2 is 128.2. okay, you know it. And the port ID of the fast Ethernet 03 is 128.3. 3. Okay, because of that, the local port ID is the port ID of port 2, and because of that, this is the designated port. Okay, in real scenarios, in real networks today's, rarely you are using the hub. Because of that, in most cases you don't have more than 2 interface in one link. Okay, but here only we are practicing. Because of that, I use this scenario with the hub. This is designated port, and now you know that all of the interfaces except the interfaces that are root port or designated port are the block. Okay, but here we have one notification. Let me talk about that. You know that in the previous scenario we saw that the interfaces that interface does not have any role include the root port or designated port, or is the alternate port, and the state of that interface is block. Okay, here we have again 2 interface, the port 2 of switch 6 and port 3 of switch 5 without any role. But here we have one new term. We call the port 2 of the switch 6 alternate. Okay, and port 3 of switch 5, okay, backup. I will talk about that. Okay, let me to explain this. This is the backup port, not alternate. Let me to write here. Look at here. In STP, in the standard STP or in the traditional STP, okay, we have these rules: root port, designated port, okay, and after that block port, and here on the about the state we can say that root and designated ports have the state of forward, and the block has the state of block. But in Cisco terminology, Cisco STP, we can see these terms: root, okay, designated, okay, root designated, then alternate, and after that backup. We have 2 new terms in the implementation of the Cisco. Alternate and backups are 2 types of the block. Let me to talk about this. When you have one interface, okay, that this interface doesn't have the role of the root and designated, and we need to find to block that interface. Okay, here we have 2 conditions. The first condition is, for example, for the port 2 of switch 6, this interface after failing the root port can be a new root port. Look at here. If the port 1 failed, the port 2 is the new root port. Because of that, we call it the alternate port. The root port, if failed, the alternate port, okay, can be a new root port. Also, when the designated port failed, the backup port can be, for example, change is converted to the designated port. Look at here. Assume that the port 2 of switch 5 now is failed. And after that, the port 3 of switch 5, you know, that is the new designated port. Because of that, we have 2 type of block. The first type of block is the port that port can substitute the root port, okay, or can, for example, convert to root port when the root port fails. And the next type of block is the backup, and when the designated port failed, the backup can be a new designated port. Cisco wants to give you this opportunity, this chance to, for example, finding the next role of the block interface. For example, when you are verifying the show spanning tree, you can see alternate. You can understand that this interface can be a root port when the root port fails. Or when you see backup, this means that when the designated port fails, this interface can be backup. This is only for giving the administrator more information, but actually both of the alternate and backup, okay, roles, both of them are block. Okay, because of that, in most cases we don't need to understand or think about the backup and alternate. Both of them are block, and also both of them have the block state. Okay, this is only a role name invented by Cisco STP for better, giving more information to the administrator. Maybe in simulators you can see the backup, but this in the real for example networks, you will see the backup when you are experiencing such scenario. Also, let me to give you one another information